So let's note down all the points that we have to do before the length matching. You can say the checklist, right? So this will be the checklist before length match. Okay. So again, this is I've included this point so we can discuss that. So and I didn't note it down anything like on my notebook, like okay, I have this set procedure. So according to you people, what should be those points that that should be there before starting the length match? Anybody wants to try that? What will be the first point? Anyways, so from my end, if I have to do the length match, so first thing I'll ensure like those will be the minimum length that we can going for. Like apart from that, anybody in the world, any designer in the world can't reduce the length further. That will be the minimum length of the interface. Okay, so the first thing is the length of the interface should be minimum. For example, I can show you. If I'll open our design, okay, and here you can see. So if you'll compare both of these interfaces between the memories, and you can see this is the longest connection here, right? And I'll show you the way from there you can see what is the longest track. So anyways, you can see this is the longest connection here. Let's suppose this is the one, right? And what is the maximum length of that connection? The total length is around 23. Yeah, around 32.58 mm. Okay, this is the total length of the this particular connection, right? So I mean, can't we go or how we can minimize that length? So if you'll see on other layers, we have lot of space empty, right? So if instead of going from the same layer, if I switch it to layer 2, you can see I can route this like that directly, right? So that means there is one more option. By that we can reduce the length of the track, right? So again, this point is about these options, right? You have to firstly just figure out any way to minimize the length of the interface. Okay, only after that you can go for the length match. Now what will be the next point for length match, or before going for length match? The clearance, right? So the clearance of the interfaces should be as per design guidelines. So what we generally do, basically, like when we start the interface or when we start the high-speed design, I mean, this is a kind of good way to do that. Otherwise you can't able to finish your layout, right? So when we start the designing, what we do, we don't follow, and we can't able to follow the clearance rule there, right? Because first priority is we have to make the interconnect between the other component and our SOC, right? So this is our priority. So just after that, you can't do the length match. Firstly, you have to implement the clearance rule. You have to just either it is 2 times of the width or 3 times of the width, whatever the rule that is either given by the manufacturer or defined by the standard, or you have simulated the kind of interconnect, okay, and you have defined the constraint by your own. Okay, so whatever the rule you are following, you have to implement that first before going for length match. Now the third option. The third option is you should have the space for serpentine. So as you can see right now, that we're going to do today. So if again I'll switch it to layer 1. So as you can see, can I do length match on this section or on this section? So you can see these are very small interconnects, right? Okay, so can I make this, this will be almost, I guess, 15, or yeah, you can see it is 15.2 mm total length. So can I just, by adding some serpentine or by adding some length matching tools, can I make it 30 on this space? And if I able to do that on this space, what about these tracks? For these tracks, can I do that length matching? No, right? So the solution is we have to kind of spread all those tracks on this section. That's why this all section is kind of empty, right? So you have to spread those tracks first before starting the length match. So this is one more point. So just spread the routed tracks, or you can say the interfaces tracks, especially the smaller one, especially the small connections. Okay, only then you can go for the, now what will be the fourth point? Apart from that, yeah, one more point I just wanted to tell you. So how you will know, okay, this much spreading of the track is enough? How you'll know that, right? So again, pick the maximum track length. For example, we have picked this one, which is around 32 or 33, right? If I'll select that, it is 32.5. Okay. Now spread those track, for example, this one, and spread that like that. So your length will be almost same in the range of 30 or 32, for example, like this. So before the length was around 15 or 16, and now it is 36. I mean, it's a little bit higher. So you can just make it smaller. So as you can see, it's in the range of the maximum track, right? So this much spreading is required for all these tracks. Only then you can able to do the length match, right? So this is again a third point, which will kind of easy things for you. So the spreading of tracks can be, or you can say the length of spreaded tracks. Okay, I hope you got my point, right? So spreading of the tracks can be closer to the max length, or should be, okay. Okay, so these are 4 points, I guess. Apart from that, you can think about it, and you can add your own point, and you can let me know on the WhatsApp group as well. So yeah, so that would be yeah, your contribution on the length matching side. Apart from that, yeah, so one more thing. Okay, so these are all the points, I guess, I just wanted to discuss before length matching. Let's quickly go for the length matching, right? So just minimize those, open the Altium Designer. Let's shift it here. Okay, so again, what will be the first step here? The spreading of tracks, right? Again, the first step should be, we have to go for further minimization of these lengths, whatever, like it is 32, 35, whatever it is. Yeah, I mean, we have to follow that. But here, due to like time constraint, because we can't do everything live, but again, my concern was I should have tell you this, okay, because when you will be doing that, so you can do with the right way. And yeah, at the end, when the end design, I'll share with you people, there you can see all the tracks are properly routed. There will be like you'll not see any chance to decrease the length of the tracks further. So that I'll share at the end of this course. Okay, so let's spread those tracks. So for this one, okay, how I can spread this one? So there is 2 ways to spread this. One is like that, okay, and here you can see we have like we don't have so much space, so we can route it from here. And when I'll route from here you'll see the length of the track will be kind of so much increased, right? So then this will be the length, you know, the highest length of the track, right? So what I will follow here, I'll follow this way, right? And again, don't route very close. Just, you know, if the clearance required this much, just go for at least twice, so we can add serpentine on this. Okay, let's see another one. So here you can see some sharp edges, those you can adjust later. Okay, let's see this one. So for this one, you can see this section will be kind of bad option, because see, those two vias are at the outer edge, right? So we can just follow the other way, right? So what you can do, you can just select those, and here, right? Let's see another one. Here we go. So for this one, we have again two ways to route those. One is either we can go from here, right? Like one connection will be like that, okay? And then we can route that, you know, around this one. Another is we can, you know, go for from here and then, you know, around that, and we can, you know, kind of spread this track. So let's go for the first option. I guess that would be better. Let's see. Okay, so this track is coming from here. Okay, if I will, okay, I guess the first one would, second one would be better, right? So let's go with the second one, that is around that, because then from here and there the tracks will become closer, right? I mean, you can try both of them, and which one would be better, you can just follow that. Just route it quickly. Okay, perfect. Let's go for another one. Okay, so here you can see, I guess routing around those would be better option, right? We'll see. And if, you know, kind of length will be really high, then we can again kind of shrink those connections. Okay, here we have to just adjust those. Okay, let's see another one, this one, right? So I don't think we can route around that, because that would be difficult. So let's follow this path. So I'm not saying this spreading is enough, right? Maybe you have to change the layer if you'll not get, you know, enough space. Okay, same we'll do for this as well. Okay, what next? Okay, next one will be again. So you're seeing things are, you know, getting complicated, right? Like when we go for length matching. That's why like length matching is so much time consuming stuff. And, you know, at the end you'll realize, okay, this length match is not correct. When you do that, when you finish your work, and you have to delete all the stuff and go for another iteration, that would be like more painful. So that's why just firstly think of every point and then go for this thing. Anyways, okay, just do the same for this one. Let's see if we can route those. Okay, let's see what is the length of this one by default. It is 20. Okay, Apart from that, we have these, I guess, data strobe signals. Okay. And what is the length of this one? Okay, this is again 26. So we have to split those as well. Now how to do that? So instead of routing this, let's create some space on this section. So how we can do that? We have to shift those differential tracks. Okay, so these are the clock signals, and let's see what is the length of those. It is 23. So that means those also needed length matching. For this one, instead of routing like that, we'll go from this way. Okay. So now we have this section for spreading these track. Then we'll have some space so we can, spread that clock signal. Let's see. So to route that, okay, just follow this way. Just imagine like how I have routed all these signals on the 8-layer board. It took me almost 1 month to route those. This is a kind of okay, so we have like this interconnect very close to the point. So the solution is, okay, let's see the solution for that. Okay, now it's fine. So let's route that as well around this so we can maintain the length. So again, the idea behind the spreading is like here on these track you don't need it so much, tracks to route or to length match, right? So right now it is 41, right? We can further reduce that by kind of shrinking those track, which we can do easily, right? Reducing the length is kind of easy, but like we have to increase the length for these track, like for example this clock will be really difficult. Okay, why we have added here? Okay, let's go for another one. Okay, so for this as well, I guess we have to reduce the length, and how we can do that here. Right. Okay, let's try this one. Sorry, this was differential. So again, you can route these tracks closer. Why? Because we have space here as well, right? So whatever the length or whatever the serpentine required for these, we can do here as well, right? As like instead of doing it here. So yeah, so So you have to just think parallelly and decide okay where you can place those serpentines instead of bulking those at the same place. Okay, so you can see now we'll have like lot of space to route those tracks for the strobe signals, right? And if required further, you have to create some more space by shifting those in this direction, right? You can delete those vias here for now, and later you can place those. Okay, what is okay? Now this one more connection. Perfect. So now you can see I have created a lot of space, like we can length match this section, or we can fill this section with the clock, and apart from that we'll have this section as well, right? Same you can do for that as well. Let's start the length match. Okay, so let's start from this one. Okay, from the so let's see what is the length here. Okay, so it is already 40. How we can reduce that? Let's shrink those slowly, and you'll see the length will be exactly same as required, right? It is still 39. Hold on. So sometimes like here you'll see the wrong information, right? So what you have to do, you have to just select the track and press tab, right? So then you can able to see the selected length, which is the total length of the track, right? Let's reduce here as well. Now press tab, it is 36. We have to reduce 2 more mm. And can we go around these vias? Hold on. If we'll go like that, okay, so now we'll have like more scope to reduce the length for this track, right? So now it is 35. Okay, from here I guess. So we have to go for 32, I guess, right? So I'm just so okay. Yeah, I forgot to tell you one more thing. So how you will see 32 is the maximum length of the track. Like any other track can be longer than that, right? Because see, let's suppose you are using a design where you have like multiple processors or something like that. So again, it would be difficult to define the tracks, right? Or the track length. So the right way to do that, just go to the PCB, okay? And from here, just select the interface. So here you have to kind of define the interfaces that we're going to use. So in our case, let's suppose we have this DDR-D, okay? Apart from that, yeah, let's take on this one, okay? Let's see what is the maximum length for that. So you can see here, whatever the nets under that class, those all will be listed here. So like it is 72 number of nets under the 50 ohm DDR-D class, right? And you can see here they have given this option, that is the routed length in mm, okay? And these are all the tracks, right? If I'll select on this one, you can see the maximum length of the track, which is this one. It's around 37.7, right? And you can just verify that as well, and we know that it is the maximum length, right? If I'll select that, okay, it is 35. I don't know why it is showing 37 here. Okay, so I mean, you can see, at least you can know, okay, this is the maximum length, and you can verify from here what is the length here, right? So it is around, if I'll tab one more time, okay, one more thing. So why it is 37? Okay, Altium is showing the correct value. If I'll go to the multi-layer mode, you'll see for this particular track we'll have some track at the other end of the, or you can say at another layer as well, right? So that will also we have to consider, right? So that means you have to not only tab for the length, you have to just press double tab. Okay, how to do that? Let's suppose this one, press one tab and one more, right? So it will select the via, it will select whatever the things we have routed on the line, it will select all of these and it will show the total length here, right? So yeah, so you can see the total length is 37. That means we have to further reduce it. How to do that? Let's go for this quickly. So start the length match. Let's see, 36. Okay, so now it is fine. 35. How else we can reduce it? Any other way to do that? Because see, when I'll shrink that, all other tracks are also shrinking, right? So there will be like, this space will be kind of consumed with other spaces as well, with other tracks as well, right? So let's do that and we'll see that later. Okay, so now I guess it is fine. Okay, so this is 32 and this is 35. Okay, let's go for 35 right now. So that means the maximum track that we are going for, which is 35. If I'll double click on this again, and you'll see it is 35.313. You can note down this value. Okay,